Are you planning to set up your own data center? Then, what is the right way to build a data center network? Watch this video. Welcome to the world of data center network. Welcome to CCNA 200-301. Implementing and administering Cisco solutions. Chapter number 27, Spine Leaf Network Architecture. Learn CCNA with Irash Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar. In this chapter, we will understand the best way to build a network for east-west traffic flow by using spine leaf architecture. Before we talk about the data center networking concept, we need to first discuss about the enterprise business networks. In the last chapter, we were talking about different enterprise business network like Tier 2 network and Tier 3 network. If you haven't watched those videos, please watch those videos first and understand the concept before jumping to the data center networking. So for a standard enterprise business network, it has three layers. They are Tier 1, Tier 2 and Tier 3. And those layers are also known as access layer, distribution layer and core layer. Each layer has its own functions to perform. The function of the access layer is to provide the network connectivity to the end user devices like printers, computers, access point, etc. The function of distribution layer is to provide the network connectivity to the access layer. Also, the distribution layer manages the routing, quality of service and access control. In addition to that, the critical services like servers, storage, that also can be connected to the distribution layer. The function of core layer is to provide fast and reliable connection to the other distribution layers of the network. They are working as a fast connectivity hub between the multiple local area networks. So this is the basic concept of an enterprise business network. So what is the difference of a data center network over the enterprise business network? That is what we are going to discuss in this chapter. So before we jump into the data center networking concept, first of all, we need to understand north-south traffic flow. What is the north-south traffic flow? The north-south traffic flow is mainly visible in the enterprise business networks. In the picture, you can see an enterprise business network concept, which is a three-tier network diagram. Here, how is the traffic flowing? Traffic is flowing from north to south and from south to north. Let's see how this traffic is explained. So here you can see the end user devices like PC, it is connected at the access layer switches, and the critical services like server, it is connected at the distribution layer switch. So this PC want to access the server. So the PC sending the traffic from here from the access layer to the distribution layer to the server, and server respond to that traffic from the top to the distribution layer to the access layer. So this traffic is going from south to north and north to south. Moreover, we know there is an internet cloud from the service provider which is connected to the core layer. So what if this PC want to access the internet? This PC want to access something from the internet. Then this PC send the traffic from the access layer through the distribution layer, through the core layer, it is sending to the internet. And the internet send the response from the service provider through the core layer, through the distribution layer, through the access layer to the PC back. So this traffic is also considered as flowing from south to north and from north to south. So this is the concept of north to south traffic flow. Now let's see what is the east-west traffic flow. We are considering the same network diagram that we were showing in the north-south traffic flow. So here, what if this PC want to communicate with this PC? How the traffic is going to flow? So the traffic is going from this PC through the access layer to the distribution layer. And from distribution layer, it is going back to the access layer again and it is reaching to the destination. So when you see the direction of the traffic, here you can see the traffic is going from west to east, and when this PC respond back to this PC, it is going from east to west. So this kind of traffic flow is considered as east-west traffic flow. The east-west traffic flow is not considered as very important in the business enterprise network, because in the business enterprise network each services are categorized as a layer. The end user devices are connected at the access layer and the critical servers are connected at the distribution layer. The other local area network are connected to the core layer. So here the intention of business enterprise network is the end user devices used to access the critical service which is located at the distribution layer and core layer. So they always consider the north-south traffic flow. This east-west traffic flow is mainly happening in the data center network. That is what we are going to discuss in this video. What is a cloud? Here we are not going to talk about the cloud exists in the sky that goes for the rain. Here we are going to talk about the concept of cloud in the information technology. So let's go back to our entrepreneur James, who has started his own ice cream company. Initially he was doing the business at his home, and when it expanded, he moved his office into a leased office space. He created his own enterprise business network and he was hosting the server and other critical services internally. Since he was hosting all of his critical services inside his business unit, there was lot of point that he needed to be considered. First of all, he needed data center location inside his business unit. It should be running 24/7 without any interruption. He need uninterrupted redundant power unit to run the data center. He need the redundant connectivity to the internet to make all of his service live all the time. Moreover, he wanted a team of IT department to take care all of his servers. And when his servers hardware and software is getting outdated, he want to invest huge amount of money to upgrade those hardware and software. So when he considered all of this point, he decided to move all of his critical services into the cloud. So what is a cloud actually? The basic concept of cloud is it is a data center which is located somewhere else. Maybe it is located in the nearby building or in the same country or a different country. So what is the benefit of this data center? This data center can assure 24/7 availability to all the services hosted in that data center. How they are going to manage that thing? How they can assure 24/7 availability of all the service? What if the power is down, or what if the uplink to the internet is down? So the data center is designed to provide uninterrupted services without any connectivity issue. The data center has multiple power generator which can provide all the time electricity to the data center services. It also has multiple redundant connectivity to make the services up and running. Even one link is down, still the connectivity can happen through the other link. It also has multiple power distribution unit from different power sources. Even one source of power is down, the other source of power can provide the power supply to the data center services. So in this kind of way, the data center is designed in a very accurate way to provide the services to the customers. This data center has an SLA, that means the service level agreement to the customer, like 99.9% their services will be up and running without any interruption. Now we can say there is only one data center at a physical location. So this data center team is thinking about one point. What if anything happen to this physical location? What if there is a fire happen or any natural disaster happen? So they decided to extend their data center into another physical location. So they set up their second data center in another physical location, third and fourth in multiple physical location. So even one physical location is down due to any natural disaster, still the services can run from the other location. This location is spread all over the world. This main data center, it may be in US, and the second data center may be in UK, and this data center may be in India, and the fourth one may be in Africa. So in this way, the data center spread at multiple country. Even there is an issue happen with one data center located in one country, it is not going to affect the customer access to the services. So this is the concept of cloud. It is not restricted to one physical location. It is spread at multiple location. This is the concept of cloud. Now let's talk about the data center networking concept. So the data center is basically means a cloud because it is located at multiple geographical location. Even one location is failed, still the other location can deliver the services to the customer. What is available inside a data center? Inside the data center, we will have multiple data center racks. This is also called the network racks. So what is a rack? Rack is a dedicated metal framework that we are going to install the devices like servers, network switches, etc. Racks are available in multiple sizes, and most commonly in data center we are using 42U racks. 42U means it has 42 unit to install the devices. So here we can say these are the unit. In this way there are 42 units available to install the network devices or the system devices. Nowadays most of the devices are rack mountable devices that we can install properly inside a rack. So this rack will have the power distribution unit installed to deliver the power to the devices. They may have redundant power distribution unit which is called PDU. This PDU may be from the electricity source 1 and this PDU may be from the electricity source 2. So why do we do like that? For some reason, if the electric source 1 is failed, but still the devices can get the power from the electric source 2 and vice versa. That's why we are using this redundant power supply. So in this rack you can see multiple devices are mounted. This is one device, second device, this is one of the server, another server, one switch, another switch, another switch and another switch, and this is one of the server. So all of these devices need the network access. So how this network access are getting? In each and every rack there should be one main network switch which is called TOR switch. So what is the meaning of TOR switch? TOR switch stands for the top of the rack switch because normally it is going to install at the top of the rack. That's why it is designed to install. So this switch provides the network connectivity to all the devices that is installed in that rack. For example, this rack has its own top of the rack switch, this rack has, and each and every rack has its own top of the rack switches. And if these two racks need to communicate, we can take uplink from this switch to this switch so that both rack devices can communicate. So this is the basics of data center networking concept. Now let's see how James is going to set up his data center connectivity. So initially James has 3 network racks which contain all of his servers and critical services, and he set up a series connectivity in between the network racks and connected one uplink to the internet. So James has rack 1, rack 2 and rack 3. Each rack has its own TOR switch, top of the rack switch. And each rack contains servers, storage, database, other network devices, etc. So James made a series connection in between the racks and to the internet. Each rack is connected in series from TOR switch to TOR switch and one uplink given to the internet. So all of these rack devices can access the internet using this R1 because all of the racks are connected in series. So here do you see any problem with this kind of connectivity? Let me tell you, what if this connection breaks in between rack 1 and rack 2? That means the rack 2 and rack 3 cannot access the services from rack 1 and from the internet. And what if this connection failed? That means R3 is going to isolate from R2 and R1 and from the internet. So this is not the right way to connect a data center networks. For that we need to follow the proper data center networking concept. That is what we are going to discuss next. So now James is going to take the help from the data center networking team to set up his data center network connectivity. So the data center networking team designed a connectivity diagram for James, and that is what we are going to see right now. In that design they connected 3 networking racks from James into an upper distribution layer, and they made the connectivity like this. Here you can see each rack has a redundant connectivity to the upper layer. Even one link is down, the network connection can happen through the other link. So in the data center networking concept, this layer is called leaf and the upper layer is called spine. Now this is the initial setup of James data center connectivity. Now what if his network grow up? What if you want to install more network racks? Then how it is going to set up? Let's see. So James extended his data center or the number of racks. So he has a second data center network which is coming like this. So this is the second data center network that James created. Now how these two data center network can communicate? For that he need one more upper layer, and each data center network will be cross connected. Now here you can see each network rack from each layer has a redundant connectivity to its top layer. Even one link is failed, the network communication can happen through the other link. So this is the basic concept of data center networking. In this way, when there is more data center network comes up, each data center need to be connected to the main core layer. This is the core layer. So this is the basic model of data center networking concept. It is also called spine leaf network architecture because it is basically look like a spine and leaf. So this concept has two layers. The layer 1 is called leaf and the layer 2 is called spine. Spine layer is considered as the backbone of the data center network. Its main function is to provide the network connectivity to the leaf layer, and the leaf layer is mainly used for the server connectivity. For that, Tor switches are using in the leaf layer. Tor switches stands for top of the rack switches, and its main function is to provide the network connectivity to the devices that is available in that specific network rack. So in this picture you can see 6 network racks: rack 1, rack 2, rack 3, rack 4, rack 5 and rack 6. Each network rack has its own Tor switch, and this is the switch that represent the Tor switch, this one. And here you can see the Tor switches are not connected in series with the other Tor switch. Instead, each Tor switch is connected to the spine switch. So from this Tor switch, one connection is going to this spine switch 1, and the second connection is going to this spine switch, that is the switch 2. So why do we connect like this? There are 2 points for this kind of connection. One is for the redundancy. So what is this redundancy for? Redundancy means, so even one link is broken, still this network rack can get the connectivity using the second link. Even one switch is broken, these racks can get the network connectivity using the second spine switch. So that's why it is redundancy. And second one is for better bandwidth. When this rack utilizing 2 link at the same time, it can get the bandwidth of 2 link at the same time. For example, if this link provide 10G speed and this link is also provide 10G speed, then total bandwidth can be 20 GB per second. So in this way, the networking device can get maximum bandwidth by accumulating the link speed. So in the spine leaf network architecture, you can see the connections everywhere. Full mesh between spine and leaf. So if you watch this diagram, you can see each network rack has multiple connectivity to the spine layer, and totally there is full mesh connection between spine and leaf. Another goal of spine leaf network architecture is it provides lightning fast east-west traffic flow, and that is also combined traffic. Combined traffic means the total bandwidth will be the combination of the speed of each link. For example, if one link is 10 Gbps speed, then 2 link can provide 20 Gbps speed for the network traffic. To explain this, we can consider the network diagram that is showing in the screen. Here at rack 1 there is a server connected, and at rack 6 there is a storage connected. So this server want to communicate with the storage all the time, and it's need to send heavy traffic to the storage. So if the server want to communicate with the storage, what is the best way to go there? So the server can use this link and reach the switch number 1, and from there it can reach to the rack 6. This is the one link. And the second link is the server can reach to the switch 2, and from there it can reach to the R6. So which link the server will use to reach the storage? The link 1 through this switch 1 or the link 2 through the switch 2? So in the data center network, the server will use both the link at the same time. You know why? To utilize the maximum bandwidth. It can load balance the traffic in between the multiple link, and it can utilize the accumulated speed of each link. For example, if the link has 10 GB speed and the link 2 has 20 GB speeds, then the total bandwidth available for the communication between server and storage is 10 plus 20, that is equal to 30 Gbps. This way the network traffic can be use the complete bandwidth, and it can load balance in between the multiple link in a data center. So in this chapter, we have understood the best way to build a network for east-west traffic flow by using spine leaf architecture. Thank you very much for watching, and subscribe to the channel for more videos. Enhance your skills with iRush Academy.